Hello friends, welcome to another video on Sundial. In my previous video, I talked about the history of Sundial and how the human civilization used Sundial in ancient time for a timekeeping device. Now, here in this video, I will talk about the step-by-step process, how to build your own Sundial, and there is your own solar timepiece. Now, Sundial are different types. Sundial are classified into the number of different types, mainly by the plane in which the sundial lies. And there are mm, different types of sundial as horizontal sundial, vertical sundial, equatorial sundial, and polar dials and analytic sundial. So uh, here in this video, I talk about the equatorial sundial because equatorial sundial is the basis of all sundial, and you can easily convert the equatorial sundial in different types of sundial like vertical, horizontal, polar, analytic. Now, before talk about how to make the sundial, you need to know the mathematics of the sundial. You see the sun and earth system. As you know, the axis of the earth is tilted about 23.5 degree. Okay. So if you consider the axis of the earth as a stick, then the sun rays will cast the shadow. Uh, Now, if you consider a horizontal plane, then this shadow will lies in this plane. Okay. Now, you know this total angle is 360. So 360 divided by 24, which is the duration of the sidereal day, and this comes about 15 degree. So if you draw lines 15 degree apart, then each line will represent 1 hour. So by that way, you can actually make a sundial. And this sundial, the plane is actually parallel to the equatorial plane. This is why it is called the equatorial sundial. Now, you live in a different position, not in the South Pole or North Pole. Suppose say you are here and the latitude of this position is lambda. Then this is your horizontal and this is the vertical and this point is called zenith. Now you need to find the axis which is parallel to the North Pole. You can easily find out if once you know the latitude of this place. So this is the stick which is parallel to the earth axis. So this axis can act as a gnomon, which is called gnomon, Gnomon. And this gnomon will cast the shadow over a plane, and that plane is perpendicular to the gnomon, okay, because it need to be horizontal with the equatorial plane. So let's make the equatorial sundial. We need to have some cardboard, chart paper, marker pencil, protector, compass, or smartphone, and bamboo sticks, small stick which used in cooking, and color for decoration. Now, using a compass, you can actually find out the north, true north. Here you see the true north position. You need to align the axis, that is the normal, in that direction. You just use a stick and this normal will parallel to the true north. Okay. And once you have a smartphone, you can also easily find out the latitude and longitude. Okay. This latitude is 33.29 and longitude. Now make the dials of the sundial. Now use a cardboard and make a point here about the cardboard and just draw a parallel line here and make some mark on 15 degree, 30 degree, 45 degree here and just draw the lines to the center. And this line is 15 degree apart and each line will represent 1 hour. Okay. So if you mark here is 6 a.m., then this line is 7, then 8 and 9 and so on. And here it will be 6 p.m. Okay. Transpose this cardboard here in this panel. Now, this is the triangle, and this angle actually, this is the cool latitude, that is 90 degree minus lambda. So, lambda is, as you see in my previous slide, it is 33.29. So, just put the lambda here, it's 33.29. Okay. And this angle will be 90 degree minus 33.2. And this angle, which is the Norman, is lambda, that is 33 degree 29 minute. Okay. And the sun rays will come from here, and it is the true north. This position is true north, and this actually casts the shadow over this dial, and from that we can actually measure the time. Okay. So this is my the real picture of my own sundial. As you see, the Norman, the stick is pointing towards the true north, as you see. Okay. And the sun rays cast the shadow of this stick over this dial, and you can easily see this time is 8:30 a.m. Okay, but from here you see that it is not actually the 8:30, it is 8:15 or something like that. But this time is called the solar time. Okay, the local solar time. So we need to correct this time with the help of some mathematics, which I discuss. Now, where I live, the longitude is something about 87 degree, and the Indian Standard Time is around 20, 82.5 degree. Suppose take 87.5. So difference is almost 5 degree. So as I live the east with respect to the my own highest, that is Indian Standard Time, and then you just multiply it with 4, that is each degree at 4 minutes, so this is about 20 minutes. Now see, there is a 20 minute, uh, I am 20 minutes ahead of the Indian Standard Time. So from 8:30 to you just take minus of 20 minutes, then you can easily see it's match the digital time, that is the Indian Standard Time, which is about 8:10 a.m. Now we need to have another correction, which is called the equation of time due to the eccentricity and the tilted plane of the Earth rotation about the sun. So as you see, in a different month of the year, the there is some the solar time is fast or slow. Okay, so as I am discussing about September, as you see, in September, uh, most of the time there is no lag. So we need to, you don't have any need to do any correction for the equation of time. But if you are in, if you check the solar time in February or March, you see there's almost a 15 minutes slow. But in May, it is about 5 minutes fast. So in that way, you can correct your solar time, um, and you can match the solar time to the in your local time. That is in the local time with the standard time. So I think in this way you can make your own sundial and enjoy the ancient solar time timekeeping device. Thank you all, and subscribe my channel. And for any, press the bell icon, and for any query you can make the comment. Thank you. Thank you for your patience.